Okay. So the review actually starts over here, just so you know. So it says homework number 36 and 37. So definitely have plenty of review problems here in this actually serving as homework. So we have that. I also gave you guys a new review pack with the answers as well. So once you complete this stuff, you got more review. So there should be plenty of review. I could try making it Delta Math if I have time, but I think this should be sufficient. If you go back and look at all the old Delta Math assignments, I think 32 and 34 Delta Math assignments. You could do that too. That's also good. Um, and yeah, any questions on the homework you guys are curious to know or ask about? Well, Peter asked a really good question about number 19. I could go over that for you guys because the answer key was a little long-winded, but I could show you a more efficient way for doing this one. So 19. Oh, your backpack's away. Okay, sorry. So yeah, so 19. They're asking to find the measure of the minor arc intercepted by line x equals 2 for that equation. If you graph that equation, where would the center be? It's a good review from last week. 395, thank you. And what's going to be the radius? So go 4 away. You draw your circle. Actually, it is one of the better ones. All right. And x equals 2 is a vertical line. Okay, so you got a vertical line, not quite my best looking line. And then, of course, you're going to make an arc, right? And your goal is to figure out the measure of the minor arc. So the minor arc is going to look like this. Now, one thing that can help is what if you knew the measure of the central angle? What if you knew that angle, right? Then you have to measure the arc. Not that hard, right? The problem is we need to figure that out. So what are some ways you could do this? Okay, good. Yeah, I would. Correct. Yeah, so if you have a little triangle here, this little sliver is one, the shorter leg, because you're going from the center, which is x equals 3, to the vertical line, x equals 2. That's one away. And the hypotenuse is 4. So what's going to be you can find the other side. It's not really necessary actually, but now you have enough to find this angle. We'll call it theta. What trig function enables you to find that angle? Cosine. So cosine theta equals 1/4. And then how do you isolate the angle? Theta equals what? The inverse cosine 1/4, which is 75.5. And then just multiply that by 2 and you got your answer, because that's just half, right, of the arc. So that's just kind of a cool problem that involves some trig, but drawing helps tremendously. You really want to draw this correctly so you can visualize it. And maybe drawing right triangles or things like that will help. It wasn't probably obvious from the beginning. That's why I wanted to go over that with everybody. And I don't remember all the problems that were assigned. Yeah, I think that's 37 key, that's 36 key. Anything else you guys want to ask about the homework? No? Okay. Yeah, go Faith. Yeah. What's the second one? Number 3? Number 2, yeah. Number 2, yeah. Hmm. Oh, the answer key's wrong. Miss Davis just told me. The answer key's incorrect. So yeah, so hold on a sec. So AC is 6, okay. CD is 24. What else do we know? Hold on a sec. That's 30. Oh, this is some old school stuff. You probably may have forgotten this. You guys remember geometric mean? Okay, I think. I don't know. Yeah, it kind of is using geometric mean. Yeah, and to be honest, this is like one of those, not say trivial, one of those things that from first semester we don't really reinforce all that much. Yeah, that's kind of crazy. So if that's 12, if you do Pythagorean theorem, you should get 6 squared plus 12 squared, which is root 180. Oh, wait, is that right? Yeah. So it should be, was that correct? 6 root 5? Yeah, it should be 12 root 5. Hold on. 6 squared plus 12 squared, that's 36 plus 144. That's 180. No, because 180. Wait, hold on. Oh, BD. Oh, okay, I see. I see now. Okay. AB is 6 root 5. That's 6 root 5 right there. Then if you have 6 root 5, correct. If you have 6 root 5 and you have 30 and do Pythagorean theorem again, right, you should get 12 root 5. I believe that's correct. Yeah. 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 So the answer for this one should be 12 root 5. Yeah, that's you have to remember that old concept. That's I don't know. I don't think so. I'll know more by tomorrow because we're going to talk about it tomorrow. So um it's just a concept we haven't really reinforced because I know you guys might forget that. And it's hard to see the similar triangle. It's not one of your typical similar triangles. It's a little crazy because you have this small triangle and you have the big triangle. I mean, you could be hypothetical and say, well, maybe this is like 50 degrees. So that's 40. Then that's 50 and that's 40. So then you have it's kind of like just the way this is set up. You have a right triangle within a right triangle. If that makes sense. So it kind of serves. It happens that you get the similar triangle situation. So, okay, anything else? This one? No. Okay. So let's keep moving. All right. So let's move on to the Unit 5 lecture notes. I just want to just finish off just to close some loops here. I want to set some more challenging coordinate geometry circle problems. I want kind of just to help you guys feel better about this. So I think we could just wrap this up and then you guys can do review after this. So if you go to the notes packet, we left things over here on number 7. So it's near the end of the notes packet. Actually, you're probably gonna go to like the last couple sheets.
What is the like quiz?
Oh yeah, let me answer that question. So the quiz is going to be essentially knowing these relationships.
About that?
Yeah, exactly. Yeah, no, without it. So like so essentially knowing like, hey, not quite like this, but what I'll do is actually I think I have it right here. Uh, yeah, here we go. It's called the Circles Theorem Quiz. Here, I'll show you how it's gonna look. I kind of flashed it really fast. So I'll give you a circle and I'll give you some situation. I'll call this like X and I'll highlight a certain portion of it. And I'll ask you, how does the arc relate to that? So like basically the measure arc, if you call this A, let's say called arc A, right? And I'll ask you, write an equation that relates to A and X. So A would equal X. Or what if I give you another circle? Yeah, it's up. Correct. What if I just, okay, terrible looking circle. Hold on, Reagan. This is X, and I highlight this portion. And I call this A. How's A relate to X here now? A equals 2X. Or I say X equals half A. Either way, either one I'll accept.
Are we writing like what the theorem is, or are we just writing the equation?
Just the equation, that's it. You don't have to state what the theorem is. All I care about is to understand the relationship. Now, granted, I'll give these to you on the test in the final, but it's just good to be able to recall it quickly so you don't find yourself like, thumbing through the formula sheets and like trying to, because that slows you down and creates a little anxiety. So it's to kind of help you guys just feel more confident. Like, oh yeah, I remember this. I remember this. So as long as you're going through the review packet today, you'll know these, right? I mean, you've done these already. So I'm not nothing really to worry about. I mean, the other one too is like maybe like intersecting chords theorem. If I put x here, x is a plus b over 2. But all the other ones that are you see below are x equals a minus b over 2. So yeah, and that's what we're testing on. So yeah, hopefully that seems reasonable. Yeah. Yeah, go right ahead. Yeah, actually, I recommend just doing the homework because you have to use them. Because if you use them, then you're gonna know it. I mean, I would do both, but really, I just as you go through the homework and you look at this, like it just got sort of sinks because that's how you are able to remember these so well. So yeah.
So that's all that it is. It's just
And then there's a true and false situation. Yeah. Just the conceptual things. Yeah. So like yeah.
Say these are this one is easier or harder than the homework.
I think homework quizzes are harder because I those are test prep questions. So there's the ACT style. So because those are more cryptic, you had to find like the pattern wasn't. This is more recall. That's what this is all about. If you've been doing the homework, you'll be fine. So you shouldn't have a problem. Okay. Let's do the rest of these notes here. Okay. So what's going on here? The center, of course, is at 3, -2. So I'll kind of tee this up for you guys and have you do some more. So 3, -2 is right, is your center. The radius is how long, guys? Oh, wait, no, I got it right. 3, -2, the center.
It was 3 -2.
Yeah, is that what I did? I did that. 1, 2, 3, 1, 2. Yeah, 3, -2. 3 is x, -2 what? No, I looked at mixed it up. I don't think I did. Okay. Okay. No, I get things mixed up. Please let me know. Sure.
Yeah, I can't. Can we?
First semester stuff you can.
Oh, I don't know.
This is the second semester.
So
Okay.
Look at it dying.
I'll help this while you guys do a review. How when you do a review, I can take a look. See what's irrelevant. I can help you guys. It's up to you. I can take a look. Anyhow, so that's your center 3, -2. The radius is 10. Now you're asked to find this, right? So let me erase this other line here. And let's draw this here. How far is it from 3 to 7? Or how long is the horizontal leg?
well,
Actually, it'll be 4. Because you're going from 3 to 7.
Oh, yeah.
And then how tall is the vertical leg? From what to what? From -2 to what does it look like? Actually, we don't know that. I lied. We don't know that just yet. That's not obvious. Because now we're eyeballing it. But the radius, how long is the radius? That's 10. Now you can see why we shouldn't have eyeballed it. That was actually a bad question. I'll call this y here. How do I solve for y? What would I do? Yeah. And it's going to be nasty because you're going to get y squared equals 84 if you clean it up. And y is root 84. Which, by the way, has 4 as a factor to be pulled out. So it'll be 2 root 21. So point A is 7 comma 2 root 21. Now you can do the same thing. Actually, wait, hold on. I made a mistake. My bad. Yeah, my apologies. That's not true. I know y is 2 root 21. What are the coordinates of point A? My bad. I messed that one up. What's the y coordinate right here, guys? We're at 7 comma what? At the right angle? 7 comma -2. Do you see how the y coordinate is -2 at the right angle? Right? So you're adding 2 root 21 to -2. So you have to do -2 plus 2 root 21. My apologies. So by the same token, if I go down by that same amount from -2, what will be the coordinates of point B? So the top for point A, the y coordinate -2 root 21. How do I write for point B? -2 minus, right? Correct. So you see how I caught myself there, right? Because I was like, wait one sec, does that make sense? Because I was trying to find the other ones, like they have to be the same distance, right? So you have to take the coordinate from the center or from wherever the middle is and add up and down correctly. Okay, does that make sense? That one? Okay, how would you do 9A? What would be the process for that one? If you want to prove that this works, that this satisfies the equation, what's a very simple way we can check that? Even easier than that. Just plug it in. Well, we know the center of the circle, but you can see the distance between the center and that point's 10, but I'll just plug it in. So 64 plus 36 equals 100. So pretty easy, right? But look, I won't move the screen just yet. Let me look at what part B is asking. I will move some. There we go. Can you see Connor? Good. All right. We'll back myself in the corner here. Okay. So does that make sense? We've done that. Okay, cool. Okay, so this one's a little more involved. Told you I kind of like these problems. So the circle, what was the center of that circle again? 3, -2, and 10. So I'll redraw it down here. And I'm just going to just draw a generic circle. We'll just go with it. -5, 4, which is going to be okay, totally not to that scale. That's okay. Tangent line means what? Just grazes it, makes 90-degree angle. Very good. Oh, because they told me. No problem. Same, told me. So remember what you know about tangents intersect the radius, blah, blah, blah. So what was the slope of the radius? And remember the center was 3, -2. So if you use rise over run or change in y over change in x, what do you think that is? The slope is negative, by the way, for the radius. Slope is negative because you're going down and over. How far do you go down? When you start -5, 4, you go down how much and right how much? How far do we go down? Starting from -5, 4. I'm going down how much? Not quite. From 4 to -2. How far is that down? From 4 to -2. And how far is it to the right? From -5 to 3. Close. 8. So you're going down 6, right 8, or -3/4. So that's just more visual than anything else, I'd say. Okay, so the tangent line would have what slope then? If it's perpendicular? 4/3, right? Because you got to flip it and change the sign, as we know. So what's the equation of tangent line point slope form? I told you point slope form is what I prefer. Y minus 4 4/3 x plus 5. In case you guys forget, we'll provide this for you guys. Y minus y1 equals m times x minus x1. Personally, I don't care about the fourth one in slope intercept form. I think that's kind of irrelevant, but what the heck, we'll do it. y equals 4/3 x plus 20/3 plus 4. And 4 is 12/3, so it'll be y equals 4/3 x. If you rewrite 4/1, it becomes 12/3. So plus 32/3.
Wait, why is it 20?
What's 4/3 times 5? Because whenever you multiply a whole number to a fraction, you treat the whole number as a fraction. Yeah, make it 5/1, and you multiply numerators and denominator. So, yeah. I mean, fine. It looks like that makes sense, but I'm not gonna worry about it. Okay, yeah, do expect something like this. I think this will be a good test question, like just knowing how to write the equation with tangent line. That's actually a big part of calculus, believe it or not. That's 3 years away. We do a lot of that kind of stuff in calculus. So hope you guys are comfortable with tangent line stuff. Right. Let's keep moving, just wrap this up. Okay, determine whether each of these lines serves as a secant or a tangent, depending on where it's located. And they'll write the equation of a circle after that, and then we're done. You guys can do more review. And you guys could work on homework 37. That's the next homework, that acts review, or you can do the new packet I gave you guys. So up to you guys. But today's just a review day. And I think what I'll do tomorrow is maybe we could go out the hallway. Actually, it might be tricky because there's AP testing. If there's no AP testing, we could go in the hallway. Well, because we could run the walls outside and like put review problems, or maybe we'll just stay in here because I forgot there's AP testing happening. Yeah, I'm doing right now. 6 -2. Oh, you're right. Yeah, that's what you meant, Connor. Sorry. So I go 6 away, 6 above, 6 below. Oh, so I found the center. Yeah, see how I got the center? Okay, so what we do is we have to locate, identify the x core in the center and the y core in the center. Because you have x minus 6, it means you shifted. So the original circle is like this. The most basic circle is x squared plus y squared equals some radius, right? We'll say 1. In fact, we call that a unit circle because there's a radius of 1, center at 0, 0. When you do x minus 6, you shift the center 6 right. When you do y plus 2, you shift the y coordinate down 2. So that's why it's at 6, -2. Plus, if you plug in 6 for x and -2 for y, you make each of those 0. So it helps reset the circle. The center. Oh, I just looked at the equation. You just look at it. So because the formula is this, x minus h squared. Correct. This is the general equation. And we talked about it last time where if you have h comma k and you have like a radius and a point called x comma y, this is the equation we get. So we can identify h and k from the formula. So h is 6 and y is, sorry, k is -2. Now, how do I get the other 4 points? I use the radius. The radius is 6 because the right side is r squared. That's 36. So r is 6. So I go 6 right, 6 left, 6 up, 6 down. And let me fix this. Okay. So now let's draw these lines. 2x minus 2. So 2 and the slope is 2. So I think it's pretty obvious. Is that a secant or tangent? Yeah, I'll put S next to secant. X equals 0 is a vertical line. What would that be? Tangent. Y equals -1 6x plus 5. Yeah, let me get rid of the other lines because it's getting a little convoluted here. Yeah, so it looks like this can be a tangent because you're here and you go down 1 over 6. Yeah, it's going to graze it right there.
You drew that circle?
No, I use the tool here. I cheated. I use that. Okay. That's a tangent still. It is very good. And a negative x obviously just does this. That's a secant. You can always plug in a point like 6 comma 4. That would make sense for part C to be a tangent because it will touch at that point, but nowhere else. Okay, does that make sense for 10? All right, and then lastly for 11, and then we're done. And then I'm officially done doing lessons with you guys. We just review over and over again. I know. Was that? What about potluck? Oh, during review week we can. Not so. Yeah, so E period. They get lucky because I'll be barbecuing for the seniors during E period on Tuesday next week. So yeah. I should actually tell them to bring sides and stuff like that. But anyhow, yeah, we can do something. We can do potluck, sure. Yeah. What do you guys want? Do you guys want breakfast, lunch? Well, it's only 2 times next week because only twice. What? Let me look at the schedule again. I don't remember what the schedule looks like. Let's see if I can reserve the hearth too. But no, we just bring it up here. If it's breakfast, yeah, let's see what the schedule looks like. Okay, so I strongly recommend you draw. I will give graph paper. Yeah, don't worry, you guys will get a grid. Don't worry. Okay, so we have a center point, right? We have a circle that kind of looks like this. Correct, I will. Okay, the center, just use logic. I'll give you a midpoint formula, but just use logic. What's halfway between -6 and 4? What x coordinates halfway between -6 and 4? Or on a number line? -1. And what's halfway between 3 and -1 on a number line? Well, half the distance is 2.
Oh, it's 2. Wait, what are you asking in the center?
So we're trying to find the coordinates of the center. It's 1, right? Because you're trying to go halfway between -1 and 3, which is 1. And we're halfway between -6 and 4, which is -1. Correct. Good. And then the radius, you could just use Pythagorean theorem. If you do that, that's going to be 2 and 5. What do you get, Kira? Root 29. So your equation will be x plus 1 squared, because you always do the opposite for the coordinates. Y minus 1 squared. And I'll give you the formula. Sure, yeah. Equals 29. So it helps to draw it. They're back? Good. Because it probably gets stressed when the kids are playing the. I was thinking more just when the goats are kind of taken away, they get stressed out.
Yeah.
Right. Okay. So the rest of the class, we got plenty of time. Another half hour roughly. Yeah, we could work on homework 37. So kind of knock that out. Or you could do the new review packet I gave you guys. I can see if I could try making adult math as well, just if you guys want to do that. So sure, yeah, goes ahead. All right. Alex McCurr. You just email the Hearth and it goes to his email address, and then yeah. You book it like you book a calendar appointment with somebody. Same way.